So a few days ago, OpenAI dropped their O3 model, or at least the preview of what it can do. A lot of people are debating whether or not this can be called AGI. It's a truly staggering sort of step forward in the progress of AI. But today, in this video, I will show you how to recreate OpenAI's O3 model in about 75 minutes with about $20 of compute. That was a response by McKay Wrigley to Andre Karpathy's post, and it's a joke. We're not quite at a point where we can recreate the world's smartest AI model with about $20 of compute in about, an hour or two. But here's the thing. DeepSeek introduces DeepSeek version 3, and it's very good. It's very fast. It's fully open source, and it crushes the other open source models. It's very inexpensive. We'll talk about that in just a second, but here's Andre Karpathy in his post about DeepSeek version 3. He's saying DeepSeek, the Chinese AI company, is making it look easy today with an open weights release of a frontier-grade large language model trained on a joke of a budget, 2048 GPUs for 2 months at $6 million. For reference, this level of capability is supposed to require clusters of closer to 16,000 GPUs. Right, so we think it takes 16,000 GPUs. They're doing it for just a bit over 2,000. And Andre continues, the ones being brought up today, the new large language models, they're more around like 100,000 GPUs. Llama 3, the 405 billion parameter model, used 30 million GPU hours, while DeepSeek v3, this Chinese release that we're talking about now, looks to be a stronger model at only 2.8 GPU hours, right? So 11 times less compute. If the model also passes vibe checks, right? So like large language model, the LLM chatbot arena rankings, Andre's saying that his few quick tests so far went well, right? But if it's sort of as good as it seems at first glance, then it will be a highly impressive display of research and engineering under resource constraints. Now, you've heard that phrase, necessity is the mother of all invention. So there's been a little bit of an AI race between the United States and China. The United States has prevented some of the more powerful AI chips being exported, being shipped to China. So we've created scarcity. We've created constraints in their ability to create these top-tier frontier models, or so we thought. So let's dive into exactly what this means, but let me give you the few sort of big headlines here. What does this all mean? Number one, the chip export laws, all of the things that we're trying to do to control where the various GPUs of NVIDIA go, where the best AI chips get exported to. Those export controls don't seem to be as effective as we thought. So as you know, there's been a lot of talk about, for example, pausing AI, putting some controls into how quickly we can sort of scale up AI development. EU, of course, put in some pretty heavy-handed regulation that really slowed down how quickly the citizens of EU get access to the latest AI models, kind of really slowing down their own sort of development. A lot of people here in the States also wanted to do various either heavy regulation or pause AI development completely. As I said before on this channel, the cat's out of the bag. People know how to build these models. It doesn't seem like it requires massive resources. The amount of resources we need keeps getting cheaper. The chip controls also don't seem to be working. So that's kind of like the one sort of big headline. The second big headline is this idea of open source. We've talked about how is open source AI dangerous? Should it be outlawed? Well, guess what? China's creating these models and publishing them, making them open source. And by the looks of it, these models are better than, Facebook's Llama model, for example. Llama is shown here in this light gray. So as you can see, the DeepSeek v3 beats it out. In fact, it beats out pretty much every single other model on pretty much everything. The only exception is Claude 3.5 Sonnet, which beats it out in a few instances. But the rest of them, DeepSeek v3 wins across the board versus its previous version, versus Qwen, versus Llama 3.5. Notice this is the 405 billion parameter model, the big one. We have GPT-4o, so kind of this yellowish gray color, right? So it beats it out in the MMLU Pro, GPQA Diamond, Math, AIME. So this is the kind of like the high-end sort of math competition. Code Force is absolutely staggering, right? It's head and shoulders above everything else, almost double what most of the other models are getting. And finally, here we have the SWE bench. So as you can see here, Claude 3.5 Sonnet is better, but DeepSeek v3 is number 2 and better than most of the other models. SWBench is doing sort of real world software tasks and verifying certain GitHub issues, trying to troubleshoot them. So this is from DeepSeek's GitHub page. One thing that jumps out at me here, they're saying, despite its excellent performance, DeepSeek v3 requires only 2.7 million H800 GPU hours for its full training. So that's what Andrej Karpathy was referring to. It's 11 times less than what the US trains its models for. In addition, its training process is remarkably stable. Throughout the entire training process, we did not experience any irrecoverable loss spikes or perform any rollbacks. There's some rumors that when OpenAI was training one of the models, maybe it was GPT-4, there were some issues. They had to perform some rollbacks. It was just rumors. We don't know the exact sort of details, but it's common to sometimes during the training process to have to, kind of the training goes in the wrong direction. You have to roll it back and try it again. Here, it seems, according to what they're saying here, that the training process is remarkably stable. They talk a little bit about the pre-training strategies. They say towards ultimate training efficiency. So they use the MOE, mixture of experts kind of architecture, where basically instead of having just one big model, they have sort of a collection of smaller ones called experts. So mixture of experts sort of allows the model to call on different aspects of itself to answer the question, depending on what question is being asked, what kind of expertise is needed. And so they're saying through co-design of algorithms, frameworks, and hardware, we overcome the communication bottleneck in cross-node MOE training, nearly achieving full computation communication overlap. This significantly enhances our training efficiency and reduces the training costs, enabling us to further scale up the model size without additional overhead. Now, why is this important? Well, basically what we're seeing right now is when any AI company releases some new thing that was a breakthrough, right? So for example, the O1 from OpenAI introduces that sort of chain of thought, the hidden behind the scenes thoughts of the model, how long it would be able to think about a problem, would improve its accuracy on answering any given question. Right, so that idea of test time compute. About 8 weeks after that, DeepSeek actually came out and they were able to kind of replicate that in their DeepSeek R1 series model. A somewhat similar thing happened with GPT-4, where, we've seen some really great results that were kind of unexpected. Part of the sort of secret sauce was believed to be the MOE, mixture of experts. So later, when we saw other models kind of learn how to replicate that, we saw large jumps up to GPT-4's level. So anytime somebody significantly has a breakthrough or breaks through in some aspect or another, we find that the other competitors, the other models, tend to catch up and replicate those results pretty quickly. So it kind of works like that whole idea of the 4-minute mile, right? Once the first person is able to break it, then people know, okay, so it is possible, and then they continue. So the interesting thing here is we will likely see this replicated here, in the States, in the UK with DeepMind and any other place that is developing these models will likely be able to figure out how they did it and maybe capture some of those reduction in the training costs. Because if this is to be believed, they've basically cut back on the training. They've cut it 10x. The training cost, how much it costs to build these models, to train them, that's been reduced by 10x. Next, they talk about post-training. So once the model is trained up, they do something called knowledge distillation from DeepSeek R1. So DeepSeek R1 was sort of the open source version of OpenAI's O1. So that idea of having the chain of thought, having the test time compute, those ideas were kind of captured and sort of redone with the DeepSeek R1. And now they're using that to help this new model. They're saying we introduce an innovative methodology to distill reasoning capabilities from the long chain of thought model, specifically from one of the DeepSeek R1 series models, into standard LLMs, particularly DeepSeek v3. Our pipeline elegantly incorporates the verification and reflection patterns of R1 into DeepSeek v3 and notably improves its reasoning performance. Meanwhile, we also maintain a control over the output style and length of DeepSeek v3. So if I'm understanding this correctly, so the DeepSeek R1, that was kind of the reasoning model. So think of that as the O1 model from OpenAI, for example. What they're doing here with DeepSeek v3, this is not that same reasoning model, right? So it doesn't have its chain of thought like the R1, but the R1, sort of its reasoning capabilities, its outputs, those are used to train the v3 model post-training to kind of use those reasoning steps to improve the reasoning of V3. So again, if I'm understanding this correctly, so they're using DeepSeek R1 to generate synthetic data to add some post-training to, DeepSeek V3, which is similar to what we believe OpenAI is going to be doing with the Orion model. And here they give a comparison of Qwen, the 72 billion parameter model, Llama 3.1, the 405 billion parameter model. So this is kind of the Meta's biggest, most capable model so far, and DeepSeek V3. So notice Llama is the dense model, meaning that it's not a mixture of experts. It's sort of one big model. It has a total parameters of 405 billion. DeepSeek V3 total parameters of 671. And we also have activated parameters. So these are out of the total parameters, the activated parameters are the ones that are actively contributing to the output. So the less activated parameters you have that you're using, models can be run more cheaply, faster, etc. Right? So in a dense model, you have a total number of 405 billion parameters, and activated parameters is basically all of them with a mixture of experts. Even though you have many more parameters, that the model would be larger if it was one big chunk, so to speak. We're running it like a much smaller model, making it less expensive and faster. And as you can see here, so it beats out the Llama 3.1 405B on the MMLU across all the different versions. Very similar scores on the Arc Easy and the Arc Challenge, slightly under on the Hella Swag. But I mean, as we're sort of scrolling down here, either it beats or it's competitive to the Llama 3.5 405 billion model. Now, they might be kind of cherry picking the results here, trying to show their best results against maybe the ones that Llama didn't do as well on. And this is why it's important to always kind of do your own work, your own research, your own testing for your own use cases to see how well this model performs for what you're trying to do with it. But usually these benchmarks do sort of serve as a basic kind of preliminary glimpse into how well the model's going to perform. So if this is accurate, this is showing that you can create these models for much cheaper than we previously anticipated, and we can run it much more sort of efficiently, cheaper and faster than, again, what we previously thought was the case. In terms of finding small pieces of information buried within large amounts of text, so that's called kind of the needle in a haystack approach. It seems like up to the 128,000 context length, so the context window, it does well, no matter where you put the little needle in that haystack, right, from 0 to 100% into the document. For those not aware, it used to be if you have a long, sometimes I would upload, a PDF that had hundreds of pages up to, to some model and try to have it find an answer to some specific thing that's buried somewhere in the middle. These models, they're better able to find things that are towards the beginning of a document, and then it also slightly improves towards the end. But a lot of times they kind of forget stuff in the middle, which is similar to, by the way, how humans work, right? So if you are listening to some lecture, you might remember the beginning very well, and then kind of when you feel it's coming to an end, you might remember some more stuff from there, but stuff in the middle might get lost as you kind of zone out. Large language models kind of work similarly, which is interesting. But that used to be a problem. Then I think Gemini, Google DeepMind's model, that was the first one where you just really started nailing the needle in a haystack tests. You can see that with, for example, NotebookLM. If you've tested that Google product, you can upload a lot of documents and you can ask some pretty specific questions where the answers are buried kind of deep within those documents. And I found that it does very, very well at finding and retrieving that information. So here, DeepSeek V3, at least for this context window, seems to be doing incredibly well. Here they're comparing it, DeepSeek V3 on the right to next one is GPT-4o, next one is Claude 3.5 Sonnet. It does very, very well. And specifically what jumps out is the code aspect, right? So it does better than the other two models on a lot of these. Notice code forces, right? It does 51%, whereas the other two have in the low 20s. It does really well at math, like almost 40% on the AIME, versus 9 for GPT-4o and 16 for Claude 3.5 Sonnet. Now, keep in mind, these models that were not the reasoning models tended to do not as good on those math tests. When we introduced the reasoning model like the O1, that's when it got really good. And of course, we saw some previews of the O3, which is just incredible at answering those questions. I think it almost maxed out the AIME 2024. So here's that little joke I made about AI progress hitting a wall. Yeah, here it is hitting a wall. So this is the ARC AGI. So for example, as you can see here, so as we get up to GPT-4, these are the non-reasoning models, right? So they don't have chain of thought. They can't do more thinking. They can't do test time compute. So when you ask them a question, they can't take more time to think about it. They have to kind of spit out the answer right away. The results were kind of bad. And the AIME, so a lot of the math problems kind of had a similar curve to this, right? And as we start introducing the reasoning models, the O1 preview, and then finally the O3, you can see this like incredible steep rise in their abilities, and now we're approaching 100%, right? So in this case, I think they did 88% accuracy on ARC AGI, and I think it was something like 99.8 or something like that on the AIME. What really is notable about this result, and again, if I'm understanding this correctly, and this is pass at one, meaning so it only gets one shot to get it right. If it misses, it's marked down. If it gets it right, gets it right. So the non-reasoning models used to be kind of bad at these sort of tests. The reasoning models rapidly were able to improve. This model is a non-reasoning model, but it passed some sort of a post-training process using data created by the reasoning model. So this reasoning model created a bunch of synthetic data that was used to train this model. And we see a massive improvement. So again, this is kind of a huge deal because this will be replicated by the competition. So the cat is out of the bag. So a lot of people can look at this and say, whoa, those are some great results, and begin to kind of copy that in their own approaches. So that means they can create a large model, kind of the hive queen, if you will, and have that thing create synthetic data, right? Sort of the alien eggs. And then I just realized that metaphor is not, I ruined that metaphor. Forget I said any of that. So you have sort of like the queen model that creates the synthetic data to then build the other models that are better at reasoning than if they weren't sort of trained on that synthetic data. So it's able to produce better models. So the larger reasoning model is able to use its data to create smaller models that are better than they could have created just through its own training. That synthetic data is that kind of special sauce to supercharge those smaller models. But let's put this one to the test. So you can chat with it at chat.deepseek.com. We're going to ask, what model is this? So interestingly, it goes, the model you're interacting with is based on OpenAI's GPT-4 architecture. This is probably because they're using OpenAI's sort of synthetic data to train a lot of these models. So when we ask what version is this, it's saying you're currently interacting with DeepSeek v3, an intelligent assistant developed by the Chinese company DeepSeek. By the way, a lot of other models will also say this that are not OpenAI's models. Just kind of an interesting point, I thought. But let's start a new chat, and we're going to ask it to create a HTML Space Invaders game. This model is supposed to be very good at coding, so let's see. So very, very fast, first and foremost, I gotta say. So it's got some HTML and JavaScript. So I'm going to use Live Weave to just kind of simulate some of the stuff that it does. So we'll copy the HTML into HTML. We will copy the JavaScript into JavaScript. If you wanted to test it out for yourself, you can. How do I shoot? Oh, this is quite excellent. Look at that. This actually works. I feel like left-right movement is a little bit too limited. We should probably improve how many squares it moves. But other than that, this works. I just realized you guys could not see it because I'm in the way. Here's what that looks like, basically. So everything works perfectly, I got to say, from the get-go, except the left and right movements are too limiting. We're going to say make left and right arrows move the player more. Currently, it moves too slow. Let's see if it's able to sort of add that to what it has already built. All right, so it just updated the JavaScript. We'll put that in here and let's try again. All right, that feels a lot better, I got to say. Yeah, it moves more and I can hold it down to move it further. All right, we're going to say add two stationary shields in front of the invaders. The player needs to shoot around it to hit the aliens. All right, let's try that. So far it's really good, really fast. Yeah, really impressive at how quickly it's able to generate this code. Keep in mind, this is an open source model, so you can even like run this locally, assuming you have the hardware for it. So let's try that. All right. So yeah, okay, so you got the two shields here, right? And you're able to, if I hit the shields, they stop the shot from happening. That is phenomenal. Let's add some power-ups. Have each 3 aliens killed drop a power-up the player has to catch. The power-ups can be machine gun, rapid shooting, explosive bullets, and aliens getting pushed back to their starting point. If it can do that, that's going to be pretty impressive because we did sort of multiple iterations on the code. So it's able to keep all of those consistent and also add these new things. I mean, it's not super crazy advanced, but it's certainly good, I would say. All right, so let's try that here. And for every 3, okay, so it got everything except for the part where the power-ups have to drop down to the player. Okay. So, I mean, not bad so far, but let's see if we can change that. The power-ups have to drop down to the player so the player can catch them. All right, so it did that. Let's see what happens here. All right, there's a power-up. And, okay, machine gun bullets. It teleported the things back. Okay, this is the machine gun bullets. Pretty cool. So one of the power-ups completely made the aliens cease to exist, or at least it probably like teleported them way back there. All right, that was pretty good, but I have no idea which power-up is which. All right, so let's have the powers be announced when the player gets them and also have them appear as a status in the upper right corner. Each power-up should last 5 seconds and then stop working. So we're getting a little bit more advanced. So keep in mind, we're going back and forth, meaning that it has to kind of keep in mind everything we've added already and iterate kind of on top of that. So now we're adding some sort of announcements on the screen, a timer functionality where we can see how long the power-ups are lasting. And here it is. Let's see how well that worked. All right, so machine gun activated. It does tell me which power-up I have now, which is pretty cool. It does not have the timer, although it does say power-up deactivated. Yeah, so basically when it runs out, it says power-up deactivated. And here's a few other quick challenges that I gave it in HTML and JavaScript. So this one is, for example, creating a quiz form. So just using multiple choice questions with radio buttons and checkboxes. And a submit button to calculate the score. So here's how it did, right? Which ones of the following are programming languages? And so this is pretty cool. This is pretty simple. You click submit and it gives you the score. Here's its output for kind of creating a simple choose your adventure game in HTML. Here's what that looks like. You can take various paths. I mean, it's very basic, but it's able to kind of do that. And if you're able to give it a more detailed thing, it can build it out fully. Next, I'll run through some simple bench challenge to see how well it does. I'm not even going to give it the answer. I'll just put this in there. Since it's supposed to be pretty good at reasoning, even though it's not a quote-unquote reasoning model, it's going to be interesting to see how well it performs in these. So its final answer is 20. Is that the correct answer? It is not. The correct answer is 0. We have a juggler throwing balls in the air and then seeing where each is going to be at some point in time. Let's try that. So again, it thinks through everything, and the purple ball is most likely on the ground in the same position as the blue ball. So at the same height as the blue ball, that's correct. And this is about a race. A lot of these are kind of, I don't want to say they're trick questions, but they have a lot of red herrings, and you really have to understand what happens. Basically here you have 3 people engaging in a race, like a 200-meter men's race, and each one of them does something to get distracted during the race, right? And you're supposed to figure out who came in first. The sort of hidden thing here is one of them diverts up the stairs of his local residential tower, stops for just a couple seconds to admire the city skyscape roof before then coming back to the race, which would obviously take some time, right? He took the stairs up a residential tower, up a skyscraper, right? Where the other ones, they read a long tweet, for example. Here, the DeepSeek model does fall for it, right? So it's looking at Joe, the person that, climbed up the stairs of his local residential tower and sort of summarized it. Oh, he took a brief pause, to take a look at the scenery below, ignoring the fact that, he had to climb a skyscraper, and says, well, Jim probably was the one that finished last because he, read a tweet, waved to a fan, and thought about his dinner. Here's another one where one sister lies and the other sister speaks mistruths. So basically they're both liars. It thinks it should ask the other sister which path leads to treasure. What would she say? So asking one sister to ask about the other sister, that's not true. The thing that you should do is just ask any of them and do the opposite since they're lying. Question 5 is Peter needs CPR from his best friend Paul, the only person around. However, Paul's last text exchange with Peter was about the verbal attack Paul made on Peter as a child over his overly expensive Pokemon collection. And importantly, Paul stores all his text in the cloud permanently. Paul will help Peter. So I'm going to change that to will Paul help Peter? ? To see its sort of reasoning abilities here. So it does understand that, most people would likely set aside past disagreements, and he would likely provide CPR to Peter. So I'm guessing here definitely is the most closest to probably. Here's another gem. Agatha makes a stack of 5 cold, fresh, single slice ham sandwiches, importantly with no sauces or condiments, in room A, then immediately uses duct tape to stick the top surface of the uppermost sandwich to the bottom of her walking stick. She then walks to room B with her walking stick. So how many whole sandwiches are there now in each room? These questions just boggle the mind a little bit, don't they? But DeepSeek is up to the challenge. It reads and thinks about attaching the sandwiches using duct tape to the top surface of the uppermost sandwich to the bottom of the walking stick. I think the point here is that if you attach a sandwich with no sauce or condiments, if you just use duct tape, you're just pulling off the top slice of bread. You're not taking sort of the whole sandwich. I think that's the thing that it's supposed to figure out. It might be missing that, but it does the math. And the final count is there's 4 whole sandwiches in room A and 1 whole sandwich in room B. I'm going to say that this is likely not the case. Interestingly, that's not even one of the answers, which I would think there should be. The answer is 4 whole sandwiches in the original room A, 0 in room B. Next, I'm going to take this PDF with a study about how different AI models are able to perform the correct diagnosis on these kind of exotic cases or not obvious cases in a kind of a clinician setting environment. Spoiler alert, O1 Preview just dominates, does extremely well. In some cases, I think they're actually better than human diagnosticians. So as you can see here, O1 Preview does extremely well. GPT-4 only, Physicians plus GPT-4 and Physicians plus resources are kind of here. But I gotta say, this is kind of crazy, isn't it? Same thing with landmark diagnostic cases. O1 Preview absolutely nails it. So I've uploaded that study as a PDF. Let me see how many pages it has. It has 25 pages, a lot of text as you saw there. Well, I showed you a few images, but most of the pages are just full of text. And we're going to ask, in general, do the AI models perform better than the human doctors? Based on the study, the AI model O1 Preview generally performs better than the human doctors in several key areas of medical reasoning. Overall, O1 Preview demonstrated superhuman performance in differential diagnosis and other things like reasoning, which is great. Okay, so that's pretty simple, but let's see if we can find something a little bit more complicated. So here's one line saying that the O1 Preview highlights that our most challenging benchmarks for diagnostic reasoning in medicine are becoming saturated. So let's see if it's able to find that needle in this haystack. I'm going to ask, are the benchmarks for diagnostic reasoning in medicine becoming saturated? It's saying, yes, indeed, they are becoming saturated, and sort of lists some reason for that. They're becoming saturated as AI models like the O1 Preview achieve near expert or superhuman performance. So I gotta say, so far, this DeepSeek V3 is looking pretty good. It's very fast. It seems to be pretty good on a lot of these. It's not as good at some of these reasoning questions as, for example, the O1 Pro mode. But just based on my sort of initial testing, this seems like a very powerful, very fast open source model that's, available for free on the web that you can also run locally. That's going to put up a challenge to a lot of these massive models that we have out there, closed source and open source like Meta's Llama 3.1, but trained very cheaply, very efficiently. This is certainly showing that moving forward, we're not just going to have better, more capable models. They're going to be easier to create, to operate, to run. And I don't think open source AI is going to be able to be stopped. We're very rapidly approaching a time when everybody will have access to open source models capable of some pretty advanced capabilities. Currently, this is not multimodal yet, but that is coming. And notice the pricing here. So for the API, so if you didn't want to run it locally, if you want to use their API, which a lot of people are going to use, obviously, if you're building something at scale. So the input is 27 cents per million tokens, and the output is $1.10 per million tokens. So comparing that to the Claude 3.5 Sonnet, so input of $3 per million tokens compared to 27 cents, and output is $15 per million tokens, again, compared to $1.10. Comparing that to, for example, GPT-4o, so we got $10 per million tokens in GPT-4o for the output. So again, 10 times more expensive, and $2.50 for 1 million input tokens. Again, roughly 10 times more expensive. And here they kind of show a performance for price ratio sort of optimum range. So input API price in dollars per million tokens versus the MLU Redux zero eval score. And of course, I mean, they're using sort of metrics that are favorable to them, but at least on this chart as they're presenting it, as you can see, DeepSeek is sort of, it stands alone because it's competitive to GPT-4o and Claude 3.5 Sonnet, but it's insanely cheaper than pretty much anything else. Only thing cheaper is the GPT-4o Mini. And obviously notice that this scale, it's 78 to 90. So of course, this is a little crunched in there, but still, I mean, again, you can see how, the open source models, these models can, if they're good, can be incredibly sort of welcoming to developers because they're probably going to be a lot cheaper than the closed source kind of frontier models by OpenAI, Anthropic, etc. So let me know what you think. What does this mean for open source AI in general? What does it mean for OpenAI, Anthropic? What does it mean for, US versus China, kind of the war for AI supremacy? And also, I can't help but think, what does this mean for companies like NVIDIA? If we're able to, create models at 10x reduction in price and compute, is that good for NVIDIA, bad for NVIDIA? I mean, certainly if you can do it for much cheaper, more people will get into the space, more people will be building their own models, right? If it costs $60 million to create a frontier model, there's going to be a lot of people that simply can't afford it. A lot of companies that don't have those kind of resources to spend. If it costs $6 million, there's a lot more of a sort of a market for that, or at least people that might be interested in attempting to do that. So as Andre Karpathy saying here, right? So $6 million cost, 2 months of training time. That's a lot cheaper and faster than I think a lot of people would suspect, a lot faster than maybe you were ready for. What does this mean for the industry? Are you going to test this model out? I'll leave a link down below. Let me know what you think in the comments. If you made it this far, thank you so much for watching. My name is Wes Roth, and I'll see you next time.